holes and wormholes, two of the most fascinating and mysterious phenomena in our universe. But what exactly are they, and how do they differ? Let's embark on a journey through space-time to uncover the distinctions between these cosmic entities. A black hole is a region in space where gravity is so intense that nothing, not even light, can escape its pull. They form when massive stars exhaust their nuclear fuel and collapse under their own gravity. Around a black hole is a border called the event horizon. Once something crosses that line, it can never come back. Deep inside is something we call a singularity. It's like a spot where everything is squeezed into a tiny, super heavy dot, a point of infinite density where our current understanding of physics breaks down. Wormholes, sometimes called Einstein-Rosen bridges, are like magical tunnels in space that could let you travel super fast between two faraway places, kind of like folding a piece of paper so that two distant points touch and making a shortcut between them. They come from the math and ideas in Einstein's theory of general relativity, and scientists imagine them as having two ends connected by a tunnel. These tunnels might connect different parts of space, or even different universes. But here's the catch: wormholes are still just ideas. No one has ever seen one in real life, and we don't have any proof they really exist yet. Let's compare the two. Black holes have been observed indirectly through their effects on nearby matter and light. Wormholes remain purely theoretical. Black holes act as cosmic traps, pulling in matter and energy. Wormholes, if they exist, could serve as bridges connecting separate points in space-time. A black hole has a singularity and an event horizon. A wormhole would have two ends, a mouth and a throat, potentially allowing passage between them. Black holes are stable end states of massive stars. Wormholes, according to scientists, would need a special kind of material called exotic matter that has strange negative energy to stay open and not collapse. Some theories suggest intriguing connections between black holes and wormholes. There's a theory called ER equals EPR. Don't worry about the letters. It basically says that black holes and wormholes might be linked in a super weird quantum way. We don't know for sure, but it could help solve some big space puzzles in the future. Black holes and wormholes captivate our imagination, challenging our understanding of physics and the universe. While black holes are observable cosmic phenomena, wormholes remain a tantalizing possibility. As science advances, who knows what discoveries await us in the vast expanse of space?